Folks, I made a mistake. I have realized that I haven't been doing any of the part 2s for each day. So when we click on a day and we scroll down, then there is now a part 2. And it even says when you insert the solution, continue with part 2, and there's a link and you just follow it and then you do part 2. And now the whole thing with the 50 stars makes sense. So what I'm going to do, considering as I said it's the 30th of November, is I'm going to try to solve the 4 part 2s for like days 1 through 4 that we have finished so far tonight. I don't think it's going to be too bad, considering they're normally like not that difficult after you've solved the first one, but we'll see. So let's try get this done. I'm not going to say as quickly as possible, but quickish. So part 2, day 1. By the time you realize the answer to the elf's question, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. To avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. That way, even if one of those elves runs out of snacks, they still have 2 backups. Okay, to quickly recap, what we did here is an elf had multiple items in their backpacks. We added up the calories and then found the one with the most. So now we just have to sum up the top 3. Find the top 3 carrying the most calories. What is the answer in total? That shouldn't be too bad, should it? So day 1, find most calories. We did the first sorted calories by elves first. So should we just quickly extract this? So if we do a function here that is calories sorted or sorted calories or sort calories. Then do remove this, return actually this instead. This, change that here to sorted calories by elves. Take this, delete this, run all tests. No. Low evaluate file, does that work? And then day 1 core tests. Alright, and that still passes. So now basically this main to and then we just say def in calorie sum, or sum calories by top n. So calories by elves and n, and then we do apply plus take n of sort calories for calories by elves. Then we say sum calories by top n, where n is 3. Alright, do we think that's correct? Yes, you have completed day 1. Back to the calendar. Oh, now it is actually like bluish. Day 2. Oh, we should probably commit this, shouldn't we? Day 1, it's to solution. Oh, did I not? Oh, gosh dang it. So, better. Alright. Day 2, that was the rock, paper, scissor one. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to enter round in a draw, and Z means you need to win. So previously meant which choice we should use. The total score is still calculated in the same way. Following the elf instructions, what would your total score be if everything goes according to your strategy? Okay, so instead of we had the strategy here and then our choice, and then was the second one. So this should now be like the outcome that we want, and then we calculate the points based on that. So I think actually I kind of want to copy and paste this and call it core 2, because that's going to require a little bit more change. So our choice, that now needs to change. So we need to basically say calculate our choice by the opponent's choice, and then what was this? It was the nth strategy 2, nth strategy 2. And then we have these outcomes here. We still have the outcome points. That is fine. But what we want is, we basically want like a reverse of that. We want to say like, if they chose rock and we need to win, then we need to choose paper. If they chose scissors and we need to draw, then we need to choose scissors. Okay. Should be like our choice based on strategy. So this is the opponent choice, and then the strategy. Then we need a character. This basically needs to change character to no. And then Y was Y is draw, X is lose, Y is draw, Z is win. X is loss, Y is draw, Z is win. And then what we want here is, do we still need this? Gain outcomes, opponent choice, our choice. Not really, right? Because we now know. So this would be then strategy to choice. Get in this this needs to be a def n, doesn't it? Def n. Get in opponent choice strategy. So the opponent chose paper, win, scissors, draw, paper, loss, rock, win, paper, draw, rock, loss, scissors, win, rock, draw, scissors, loss, paper, outcome points. Well, we can just do outcome to points because we always know the outcome. Outcome is strategy to character to strategy, or character to outcome. That's the nth strategy. Second. And this is outcome to choice. So our choice is outcome to choice of our choice. Outcome. Then outcome to point. Outcome to points is literally just the outcome. We don't need the choice anymore. This is just the outcome. Do we think that works? $10,334. 10,334. Nice. Very good. On to day 3. There was the which item is in both compartments of the rucksack. So as you finish identifying the misplaced items, the elves come to you with another issue. Committing. Okay, part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in the rucksack, and most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have different badge item types. So in the above example, the first group are the first 3 lines. The second group's rucksacks are the next 3 lines. And the second group's rucksacks are the next 3 lines. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. This must be the badges. In the second group, it is an uppercase Z. Priorities for these items must still be found and organized. The sticker attachment efforts, there are 18R for the first group, 52Z for the second group. The sum of these is 70. Find the item type that corresponds to the badges. Okay, so instead of splitting a single rucksack, always get 3, find whichever type is between them, and then grab the points for those. Okay. I think this will require some tests to make sure we're not going absolutely wrong. So I just want to rename this Clojure to test. I'll not copy. Oh my goodness. There we go. So 1, 2, 3, 1, 2, 3. Do we know between those? Is that were those the input lines? V'ger, blah 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 blah. So that should be 70. So that should be some badge. What do they call it? Badge effort priorities. So these are not gonna be useful here. I'm pretty sure we can make that work with just this test to make sure we're getting to the right thing at the end. But just to be certain, and that should be actually 70 for example input, and then we can say returns 1 for badge A, and then what we're going to do here is we're going to say AB, AC, AD. Okay, and then we are gonna copy day 3, Core 2, day 3 Core, day 3 Core 2. Item to priority still makes sense. Well, in that case, it should be badge to priority. Really. Oh yeah, I can get rid of this. This was remnant. And this badge to priority. Then rucksack to compartments, that's different now. So that should be like wrong items and priority, apply plus. Okay, yeah, all of this is going to be a little bit different. So what we want to do is we want to split lines in partition. So partition 3, I'm pretty sure would do what I want. 1, 2, 3, 4, 5, 6. Yep. So def in rucksacks to groups. Input to groups. Partition 3 string split lines input. So that's gonna sort that bit out. Then what do we name the function? Should probably move this over here, right? It's like split right. Some page priorities. So now we split them. So we have always a group with 3. So now what we need to do is we need to def in find page in group. Then we have rucksack 1, rucksack 2, 3, and now comes the fun part. So what I think we can do is if we do this, and then use the set as our function. Then that would find A, and if we have multi overlaps, it would find this. So what I'm saying is rucksack 1, 2 overlaps is filter set of rucksack A with rucksack 2. So that's going to give us all of the overlaps between 1 and 2. And then if we do that a second time, so then we have like if we do that a second time, then we end up with the overlap between rooks, all overlaps. There should always only be 1, but it's still going to return a sequence. So all overlaps is filter set of rucksack 1, 2 overlaps of rucksack 3. And then we return first of all overlaps. So I think if we call find page in group, A, B, C, A, D, E, A, E, F, it's gonna return A. And then we just need page to priority, right? That should still work as before. Syntax error compiling. Why did my REPL is gone? Don't need the compartments. Don't need this. That works. Input to groups, and now we just say let groups be input to groups input. Then badges is map find badge over groups, and then priorities is map badge to priority of badges. And then what we return is apply plus priorities. Simple. Input to groups. Okay. Core 2. Is that because? Yeah. Okay. Okay, that worked. That apparently also worked, so some batch priorities. Run this 2581. Nice. Okay, on to day 4. Quickly commit this again. Actually save the files. I think what I should do is I should get day 3, it's part 2 solution. Then kill the REPL. This is annoying me. Kill this. And then dot nREPL dash port dot nREPL dash port. Okay. All right, on to day 4. It seems like there is still quite a bit of duplicate work planned. Instead, the elf would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs 2 to 4, 6 to 8, and 2 to 3, 4 to 5 don't overlap, while the remaining 4 pairs 5 to 7, 7 to 9, 2 to 8, 3 to 7, 6 to 6, 4 to 6, and 2 to 6, 4 to 8 do overlap. 5 to 7, 7 to 9 overlaps in a single section 7. 2 to 8, 3 to 7 overlaps all of the sections 3 through 7. single 6, 4, 5, 6. So in the 600 number of overlapping assignment pairs is 4. How many assignment pairs? In how many assignment pairs do the ranges overlap? Like all. Okay. Any overlap, right? So when is there an overlap? When I actually have an idea. I don't know if that is better or worse than like the checks like this, but if we do a range, so then do a range here to here, and then we just say any no. Or is it some predicate collection? Yeah, so if we treat some set range 2 inc 6 of range 1 inc 3, then it overlaps on 2. And if we would go 2 to 6 and 1 to 1 to 1, how would we treat 1 to 1? Range 1 inc 1. No, that's fine. That is fine. So if we say 1 to 1 here, nil, therefore it doesn't overlap. So we have def n any overlap if, well, some set of range from 1 inc to 1 over range from 2 increment to 2. Then we have any overlap. I think. Those need underscores here. So check in load, try it. 806. Let's see. There we go. Ha! Let's look at our picture. Yay. Beautiful. All right. Well, I'm glad we got up to 8 stars and got all of our second stars here before we start Advent of Code 2023 tomorrow. So yeah, thank you very much for watching. See you soon. Bye bye.